Hello students and good morning. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is integration by parts. So today is the continuation class of this chapter. Same exercise 7, page number 381, 5 marks section from the book Higher Mathematics for class 12 by SND. So let us integrate this number, that is question number 19.1. 19 number 1, that is you have to integrate integration of e to the power tan inverse x divided by 1 plus x square whole square dx. Let us integrate it. So what is the method for integrating it? So let us first write, therefore I is equal to integration of e to the power tan inverse x divided by 1 plus x square whole square dx. Okay. So now what is the method for integrating it? So let us see the relation between tan inverse x, that is your inverse circular function, and the algebraic function, that is 1 upon 1 plus x square whole square. And you know that the differentiation of tan inverse x is 1 upon 1 plus x square. You know that, isn't it? d by dx of tan inverse x is 1 upon 1 plus x square. So in this case we can do the method of substitution. But there is 1 plus x square whole square. That means 1 plus x square whole square means there are two factors, 1 plus x square into 1 plus x square. Now let us separate this whole square, right? So we can write here I is equal to integral sine e to the power tan inverse x divided by 1 plus x square into 1 plus x square dx. Is that clear? So now we can use the method of substitution. That is differentiation of tan inverse x is 1 upon 1 plus x square. So let us assume tan inverse x as z. So let this is z is equal to tan inverse x. So differentiating both the sides with respect to x. Therefore dz by dx is equal to 1 upon 1 plus x square, right? So or what is dz now? That is dx upon 1 plus x square. That is dz is equal to dx upon 1 plus x square. Now instead of this dx divided by 1 plus x square, we can write dz. So let us put this values in I. So what does I become now? So therefore I is equal to integration of e to the power what? E to the power z, isn't it? So it is e to the power z into dx upon 1 plus x square. Dx upon 1 of this 1 plus x square is dz, right? So divided by, so what will you do with this one other factor 1 plus x square? So for this one other factor 1 plus x square, we can put x in terms of z. That is x is equal to, this is your tan z, right? So let us write here within bracket 1 plus tan square z. Is that clear? So that is, we are substituting the values of all these expression in I. That is I is equal to integration of e to the power z, right? And dx upon one of these, dx upon 1 of these 1 plus x square is dz divided by 1 plus, now you can put the value for x here. So from this relation the value for x is tan z. So we have put it here 1 plus tan square z. Okay. So let us simplify it. I is equal to integration of e to the power z dz divided by what is 1 plus tan square z? This is your sec square z, right? So or I is equal to integration of e to the power z into what is 1 by sec square z? That is cos square z dz. So I think you have understood it. Okay. Now this problem is same as the previous problem that we had done in the last online class. Okay, so now before you do integration by parts here, because in this case you have to use the integration by parts, because this is the integration of the product of two different functions, right? But there is cos square z. I already told you that whenever there is integration of cos square z or sin square z, you have to use a formula from multiple angles in trigonometry, right? If there is cos square z or sin square z, you can use the formula of 2 sin square z or 2 cos square z, right? So you have to multiply and divide by 2 here to make it 2 cos square z. So, or I is equal to, this is your half integration of e to the power z. Let us write within bracket, this is 2 cos square z dz, right? Or I is equal to half integration of e to the power z within bracket. What is 2 cos square z? This is your 1 plus cos 2z bracket close dz. Is that clear? That is the formula for 2 cos square z is 1 plus cos 2z, right? Now let us separate the term here. Or I is equal to, this is half integration of e to the power z into 1 e to the power z dz plus half integration of e to the power z into cos 2z dz. Is that clear to all of you? So I think you have understood it. So let us write it as I1, or I is equal to half into, you can easily evaluate it, that is integration of e to the power z is e to the power z, plus let us write it as I1. Again, you have to differentiate it by parts. Okay, that's why this integration is taken as I1. So let I1 is equal to half integration of e to the power z into cos 2z dz, right? So now you can use integration by parts there, because this is the integration of the product of two different functions, right? So or I1 is equal to half, let us write within third bracket, integration by parts for these two functions. Now this is the product of two different functions. One of the function is e to the power z, that is your exponential function e, and the other function is cos 2z, that is your trigonometric function, that is t. So among these two letters e and t, which letter comes first in the word let or islet? T comes first. That is trigonometric function is the first function in this case, that is cos 2z is the first function and e to the power z is the second function. So let us use integration by parts. So first function is taken outside, cos 2z integration of e to the power z dz minus integration of second bracket dy dz of, this is your cos 2z, right? That is differentiation of the first function with respect to z, then integration of e to the power z dz, second bracket closed dz, then third bracket is closed, right? So let us simplify the expression within third bracket now. Or I1 is equal to half within third bracket. Let us integrate first. What is the integration of e to the power z? E to the power z cos 2z minus integration of, what is the differentiation of cos 2z with respect to z? It is minus sin 2z into 2. Because since this is the differentiation, you have to write down multiply by the differentiation of 2z with respect to z, that is into 2. So what is the integration of e to the power z? E to the power z dz. Here third bracket is closed. Now let us multiply by half here again. Or I1 is equal to, this is your half e to the power z cos 2z, right? Minus into minus plus, this 2 gets cancels, integration of e to the power z, this is sin 2z dz. Understood? So now again you have to use integration by parts in this case, because this is also the integration of the product of two different functions, right? So or I1 is equal to, this is your half e to the power z cos 2z plus, let us write within third bracket, integration by parts. Which is the first function? You know that. sine 2z integration of e to the power z dz minus integration of second bracket dy dz of sine 2z integration of e to the power z dz, second bracket closed dz, then third bracket is closed, right? So now let us simplify the expression within third bracket. Or I1 is equal to half e to the power z into cos 2z. You can open the bracket here because there is one actually outside third bracket. So if there is no term outside third bracket, so there is one. So you can easily multiply it, isn't it? So what is integration of e to the power z? E to the power z. This is e to the power z into sine 2z minus, right? Minus integration of, what is differentiation of sine 2z with respect to z? It will be cos 2z into 2, right? Into, what is integration of e to the power z? It is e to the power z dz. Or now this is I1 is equal to half e to the power z cos 2z plus e to the power z sine 2z, right? Next, which is constant here? Minus 2 is constant here. It can be taken outside integration sign. 2 integration of e to the power z cos 2z dz. So I hope you have understood it. Will you again integrate it by parts, because this is also the integration of the product of two different functions. So now in this case, don't use integration by parts. So again, if you integrate it by parts, again you will get e to the power z sine 2z. There will be no end for this problem if you integrate it again by parts. Okay, so now instead of this integration of e to the power z cos 2z dz, you can write from here integration of e to the power z cos 2z dz is equal to 2i1, isn't it? You can cross multiply it. So what is integration of e to the power z cos 2z dz? It is 2i1. We can write here 2i1 here, right? So or I1 is equal to half e to the power z cos 2z plus e to the power z sine 2z minus 2 into, this is your 2i1. So I think you have understood it. Okay, now you have to get the value for I1. So how can we get the value for I1 now? So this is your minus 4i1. When it is taken to the left hand side, it becomes plus 4i1, that is 5i1. So this is your 5i1 is equal to half e to the power z cos 2z, then plus e to the power z, this is your sine 2z. Okay, so let us get the value for I1 now. So let us get the value for I1 now. So what is I1 here now? So let us get the value for I1 here. So therefore I1 is equal to, now you can cross multiply by 5, or I1 is equal to, you can cross multiply by 5 here, 1 by 10 e to the power z cos 2z plus 1 by 5, again you have to cross multiply by 5 for the second term also, e to the power z sine 2z. Is that clear now? So this is the value for I1. So let us put this value for I1 in I. So therefore what is I? So now we have to get the value for I actually, isn't it? What is the first term? Half e to the power z, half e to the power z plus, which is I1 here? I1 is this one. So I1 is 1 by 10 e to the power z cos 2z plus 1 by 5 e to the power z sine 2z. Okay, since we have integrated all the terms out here, you can write plus c, right? Now we have to put the value for z. Actually, what is the value for z? If there is only z, you can write it in terms of inverse circular function, that is z is equal to tan inverse x. You have to write instead of z tan inverse x. and you know that tan z is equal to x. You can convert this cos 2z and sin 2z in terms of tan z. You know this formula from multiple angles, isn't it? Or now this is I is equal to half e to the power, now what is z? This is your tan inverse x, plus 1 by 10, this is e to the power, what is z? This is your tan inverse x, within bracket, what is cos 2z in terms of tan z? So that you can put the value for tan z, which is equal to x. So this is 1 minus tan square z divided by 1 plus tan square z. Is that clear now? So next one is, since there is no space out here, let us write it in the next step. What is the third term? Let us write down here, plus 1 by 5 e to the power tan inverse x, and within bracket, what is sin 2z? 2 tan z divided by 1 plus tan square z, bracket closed, plus c, right? So now let us put the value for tan z here. So tan z is equal to, what is tan z? Actually it was x, isn't it? Tan z was x. Since z is equal to tan inverse x was there, so tan inverse tan inverse x was z, so x is equal to tan z. That means instead of tan z you can write x. So or I is equal to half e to the power tan inverse x plus 1 upon 10 e to the power tan inverse x, and within bracket 1 minus x square divided by 1 plus x square, then plus 1 by 5 e to the power tan inverse x, and within bracket we have 2x, isn't it? Instead of tan z there is x, 1 plus x square, bracket closed, plus c. So this is the final answer. So this is quite lengthy, but you can do it. So this is also important question, so you can copy it. So I hope you have understood it, so you can copy it. Now we'll do the next problem. So now we'll do the next question, that is 19 number 2. You have to evaluate this integration, that is integral of e to the power 2 tan inverse x within bracket 1 plus x whole square whole divided by 1 plus x square, then dx is also there. So let us first write I is equal to integration of e to the power 2 tan inverse x, e to the power 2 tan inverse x. The power for e is 2 tan inverse x into, and within bracket we have here 1 plus x whole square divided by 1 plus x square, then you can write here dx, right? So now in this case, this is the product of two different functions. One is exponential function and the other one is algebraic function. So let us simplify this algebraic function. We can use a formula here. What is 1 plus x whole square? That is your a plus b whole square. What is the formula for a plus b whole square? It is a square plus b square plus twice ab. Let us write down the formula now. Or I is equal to, this is integration of e to the power 2 tan inverse x. Now within bracket a plus b whole square. A square is 1 plus b square is x square plus 2x. This whole divided by, this is your 1 plus x square, then what do we write? Dx. Is that clear? So now let us separate this term. Let us separate this algebraic expression. 1 plus x square upon 1 plus x square plus 2x upon 1 plus x square, right? So or I is equal to integration of e to the power, this is 2 tan inverse x, this is your e to the power 2 tan inverse x. Now within bracket, so this is 1 plus x square upon 1 plus x square is 1 plus, now this is 2x divided by 1 plus x square, bracket closed, dx. So we have separated this fraction and we got this expression, that is 1 plus 2x upon 1 plus x square, right? So let us multiply this expression and then separate the term, or I is equal to integration of, now within bracket, let us multiply the expression. 1 into e to the power 2 tan inverse x, e to the power 2 tan inverse x, plus next it is 2x e to the power tan inverse x divided by 1 plus x square bracket close dx. Is that understood? So we have multiplied the expression within first bracket by e to the power 2 tan inverse x, that is e to the power 2 tan inverse x into 1 is e to the power 2 tan inverse x plus 2x e to the power, this is your 2 tan inverse x, sorry, this one is your 2 tan inverse x, right? 2x into e to the power 2 tan inverse x divided by 1 plus x square. We have just multiplied it, okay? So what is the method for integrating it now? Now in this case we can use different methods. You know that if you consider this term x e to the power 2 tan inverse x, so what is the differentiation of x into e to the power 2 tan inverse x? Let us differentiate it with respect to x. So which is equal to, you can use UV rule. What is the differentiation of x? 1. So e to the power 2 tan inverse x is kept as it is, plus x into, x is kept as it is. Now what is the differentiation of e to the power 2 tan inverse x? It is e to the power x is e to the power x. Here x is taken as 2 tan inverse x. Again differentiated with respect to x. So it is 2 upon 1 plus x square, right? So is equal to e to the power 2 tan inverse x plus 2x e to the power 2 tan inverse x divided by 1 plus x square. That means if you differentiate this expression, that is only x e to the power 2 tan inverse x, we are getting this expression. Actually this expression is this one, isn't it? E to the power 2 tan inverse x plus 2x e to the power 2 tan inverse x divided by 1 plus x square bracket close dx. That means we can assume this x into e to the power 2 tan inverse x as z. So let z is equal to x e to the power, this is 2 tan inverse x, right? So let us differentiate it, differentiating both the sides with respect to x. So it is dz by dx is equal to, now use UV rule, product of two different functions here. You can use the product rule. What is the differentiation of x? 1. Then it is e to the power 2 tan inverse x plus x is kept as it is into, now it is in the form e to the power x. What is the differentiation of e to the power x? E to the power 2 tan inverse x. Here x was assumed as 2 tan inverse x. Again you have to differentiate the term which is assumed as x. That means you differentiate 2 tan inverse x. That is 2 into 1 upon 1 plus x square. That is the differentiation of 2 tan inverse x. So or this is dz by dx is equal to e to the power, this is your 2 tan inverse x plus 2x e to the power 2 tan inverse x divided by 1 plus x square. That means we have got this expression, right? So let us cross multiply by dx. Or dz is equal to within bracket e to the power 2 tan inverse x plus 2x e to the power 2 tan inverse x divided by 1 plus x square bracket close. Then what do we write? Dx. So I think you have understood it. Okay. Now what is I here? Therefore I is equal to, this is integration of, what is the value of this expression, this whole expression? The value of this whole expression is what? Dz. That is integration of dz is there. Okay. Now we can easily integrate it. Or I is equal to, what is integral sign dz? That is your z plus c. Or I is equal to, what is the value for z in this case? Here the value for z is x e to the power 2 tan inverse x. So it is x into e to the power 2 tan inverse x plus c. So this is the final answer. So I think you have understood it. So you can copy it. This question is very, very important, right? So let's do the next question now. So now we'll do the next question, that is question number 20. The question is integration of cosec cube x dx. Okay, so in this case we have got integration of cosec cube x dx. So how will you do it? So for this integration of cosec cube x dx, we can separate this term as cosec x into cosec square x dx. So there is different methods for this. Since this is only one of the function, this is only one function is there, cosec x into cosec square x dx. So in this case also you have to use integration by parts. So this is the exceptional problem out here. Okay, so integration of cosec cube x dx can be written as integration of cosec x into cosec square x dx. Okay, so I already told you that this is the exceptional problem. So in this case also you have to use integration by parts, since it is the integration of only one function is there. So we have separated the term here as cosec x into cosec square x dx, and we can take cosec x as the first function and cosec square x as the second function, because you know that integration of cosec square x dx is minus cot x. You know the formula, isn't it? So this problem is also same as cosec cube x dx, that is integration of sec cube x dx. So whenever you have cosec cube x or sec cube x, whenever you have integration of cosec cube x dx or integration of sec cube x dx, you can use the same method for this two integration. So in that case also, for integration of sec cube x dx, you can separate the term as integration of sec x into sec square x dx. So in this case also we can take sec x as the first function and sec square x as the second function. Sec x as the first function and sec square x as the second function. So we will do this number 20 here. So this is your homework, because this is same as question number 20. So let's do this question number 20 now, and that is your homework, right? So therefore I is equal to, this is integration of cosec cube x dx, right? So or I is equal to, now this is integration of, let us separate the term here, cosec x into cosec square x dx, right? So now let us assume cosec x as the first function. Always take in this case cosec x as the first function and cosec square x as the second function. If you take cosec square x as the first function and cosec x is the second function, it will be complicated. You cannot do this integration. Okay, so let us take this cosec x as the first function and cosec square x as the second function. Let us do integration by parts. So cosec x is taken outside, integration of, this is cosec square x dx minus integration of second bracket dy dx of cosec x, right? Then integration of what? This is cosec square x dx, second bracket closed, dx. Is that clear to all of you now? So now let us integrate it. I is equal to, this is cosec x into, what is integration of cosec square x? Minus cot x, minus integration of, what is dy dx of cosec x? You know that this is minus cosec x into cot x, into what is integration of cosec square x? It is minus cot x, then what do we write? Dx. Is that clear? Or I is equal to, this is your minus cosec x into cot x, right? Minus into minus plus, plus into minus, minus integration of, now here you can write, this is your cosec x into, what is cot x into cot x? This is your cot square x dx. So I think you have understood it. Okay, now you have to evaluate this integration, that is cosec x into cot square x dx. So what will you do now? So you have to express this cot square x in terms of cosec square x minus 1. You know the formula of cot square x, isn't it? Again, this cot square x is changed into cosec square x minus 1. You know the formula, right? So let us use the formula for cot square x, or I is equal to minus cosec x into cot x minus integration of, this is your cosec x into, this is cosec square x minus 1, bracket close, dx. Is that clear? So now let us simplify it. Let us multiply it and separate the integral sign and dx also. Or I is equal to minus cosec x into cot x minus cosec x into cot x, then minus integration of this is your cosec cube x dx, right? So we have multiplied the term here. Cosec x into cosec square x is cosec cube x minus integration of cosec cube x dx, and minus into minus plus integration of, this is your cosec x dx. Is that clear now? So I think you have understood it. Plus integration of cosec x minus into minus plus integration of cosec x dx. Okay? Or I is equal to now it is minus cosec x cot x minus, now what will you do with this integration? How will you evaluate this integration cosec cube x dx? We have already assumed integration of cosec cube x dx as I, isn't it? Let us write I here. So this is your minus I plus, you know the formula of integration of cosec x dx. What is the formula? The simplified form is log within mod tan x by 2 mod sign close, the base is e. Is that clear to all of you? Then you have to write down plus c, because we have integrated all the terms out here. So minus I, what will you do with this minus I which is on the right hand side? Let us take it to the left hand side. So this minus I becomes plus I, that is 2i. So 2i is equal to minus cosec x cot x, right? Then this one is plus log. This one is plus log within mod tan x by 2 mod sign close plus c. But in this case you have to get the value for I, that is your required integration, right? So I is equal to 2 is taken to the right hand side, you have to write it in the denominator, minus half cosec x cot x, right, plus again 2 is taken to the right hand side, so it becomes half log within mod tan x by 2, you can write here base e, here you can write here base e, then plus c by 2 will be there, isn't it? But since c is a constant, c by 2 can be written as c. Okay, if this is constant you can write it as c by 2 is also c. So this is the final answer. So I think you have understood it, so you can copy it. So there is similar type of problem, that is integration of sec cube x dx, sec cube x dx. You can use the same method as we have done in the previous problem. Okay, so that is your homework. You can do likewise. Okay, so let's do the next question now. So now we'll do the next question, that is question number 21. The question is integration of tan inverse x dx divided by 1 plus x square whole to the power 3 by 2. So let us evaluate this integration now. So therefore I is equal to integration of tan inverse x dx divided by 1 plus x square whole to the power 3 by 2. Okay. So now how can you evaluate this integration? So in this case, first of all you have to use the method of substitution before you use integration by parts. Okay. So you know that the differentiation of tan inverse x with respect to x is 1 upon 1 plus x square. You know that, isn't it? That is differentiation of tan inverse x with respect to x is 1 upon 1 plus x square. So now let us simplify this 1 plus x square whole to the power 3 by 2. So or I is equal to integration of, this is your tan inverse x dx divided by, right? So this is 1 plus x square whole to the power 3. You can write it as within second bracket whole to the power half, isn't it? 1 plus x square whole cube, again whole to the power half, so that these two powers can be multiplied and you can write 3 by 2 there, right? So whole to the power half. Why is it written in terms of whole to the power half? Because you know that whole to the power half can be written in terms of square root sign, isn't it? Or I is equal to integration of, this is your tan inverse x dx divided by, this whole to the power half is within square root 1 plus x square whole cube, right? So again you can simplify within square root 1 plus x square whole cube. Again you can break this term 1 plus x square whole cube as 1 plus x square whole square into 1 plus x square. Or I is equal to integration of, this is your tan inverse x dx divided by, this is your 1 plus x square root over 1 plus x square. I think you have understood it. Actually what is done out here, within square root 1 plus x square whole cube is there. You can break this term 1 plus x square whole square into 1 plus x square, isn't it? This can be written as integration of, actually tan inverse x dx divided by within square root 1 plus x square whole square into 1 plus x square, right? And what is the square root of 1 plus x square whole square? That is your 1 plus x square. It is taken outside the square root, and then within square root there is 1 plus x square. So I think you have understood it. Is that clear now? So now what will you do? You can do the method of substitution in this case. Let us assume tan inverse x as z, because its differentiation is 1 upon 1 plus x square. So let z is equal to tan inverse x, right? So its differentiation is 1 upon 1 plus x square. So let us differentiate it. So differentiating both the sides with respect to x. Therefore dz by dx is equal to 1 upon 1 plus x square, or dz is equal to dx upon 1 plus x square. That is, what is the value for dx upon 1 plus x square? It is dz. Let us put these values in I, but first of all you have to get the value for x, because within square root also there is 1 plus x square. In this case we can put the value for x. So what is the value for x from here? So x is equal to, this is your tan z. So let us put these values in I. So what does I become now? So I is equal to integration of, what is tan inverse x? It is z. And what's about dx upon 1 plus x square? It is dz divided by root under 1 plus what is x square? What is x there? Tan z. What is x square? It is tan square z. It is tan square z. Okay. So or I is equal to integration of z dz divided by, what is square root of 1 plus tan square z? Sec z, right? So this is your sec z. Or I is equal to integration of z into, what is 1 by sec z? It is cos z dz. 1 by sec z is cos z dz. Okay. Now also this is the integration of the product of two different functions with respect to z, right? So here also you can use integration by parts. You know that z is algebraic function, that is a, cos z is trigonometric function, that is t. A and t letters are there. So in the word let or islet, which letter comes first among these two letters, a and t? A comes first, that is z is the first function and cos z is the second function. So let us use integration by parts. So z is taken outside. Integration of cos z dz minus integration of second bracket. This is your dy dz of z. Integration of cos z dz. Then second bracket is closed. Then we can write dz. Is that clear? So, or I is equal to z into, what is integration of cos z? Sin z. It is sin z, right? Minus integration of, what is d by dz of z? That is your 1. What is integration of cos z? That is your sin z. Then what do you write here? dz. Okay? So, or I is equal to, this is z sin z. What is integration of sin z? Minus cos z, isn't it? So there is already minus. So within bracket you can write minus cos z plus c. Or I is equal to, this is your z sin z minus into minus plus. So this is cos z plus c. So I hope you have understood it. Okay. So now you can put the value for z. What is the value for z? It is tan inverse x. But instead of sin z and cos z, what will you write? If tan z is equal to x, then you can easily find out the value for sin z and cos z. Okay. So you can get it in the rough part. What is tan z here? What is tan z here? It is x. So here tan z is equal to x, isn't it? So you know tan z is perpendicular by base turned permanently black, x upon 1. So here p is equal to x and b is equal to 1. You know Pythagoras theorem, h is equal to root over, this is p square plus b square, right? Or what is h is equal to root over, this is x square plus 1. Now from here we can easily get the value for sin z and cos z. So what is sin z? Which is equal to p by h. What is p in this case? X divided by root over x square plus 1. And what is cos z? It is b by h. What is b in this case? 1 divided by root over x square plus 1. Is it clear now? So let us write here I is equal to, what is z? Z is tan inverse x. Z is tan inverse x into, what is sin z? Sin z is x upon root over x square plus 1 plus, and what is cos z? It is 1 upon root over x square plus 1 plus c. Or you can write I is equal, what is the final answer? This is your x tan inverse x divided by root over x square plus 1 plus 1 upon root over, this is x square plus 1, then plus, what do we write? C, plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 22. You have to evaluate this integration, that is integral of log of within bracket x plus 1 dx divided by root over x plus 1. So let us write down first I is equal to integration of log of x plus 1 divided by root over x plus 1 then dx, right? So how can you evaluate this integration? How can you evaluate this integration now? So now in this case, there is within square root x plus 1 is there. You can remove square root here by writing x plus 1 as z square. So let us do the method of substitution first. Let z square is equal to what? X plus 1. Okay. So let us write here differentiating both the sides. Differentiating both the sides with respect to x. So what is the differentiation of z square? It is 2z dz by dx is equal to 1. Or let us do cross multiplication. What is dx is equal to? This is 2z dz, right? So we have got dx is equal to 2z dz. Is that clear? So let us put these values in I. So I is equal to integration of, in the numerator, log, what is x plus 1? Z square, isn't it? X plus 1 is what? Z square divided by root over z square into what is dx? It is 2z dz. Is that clear? So, or I is equal to, this 2 is taken outside, integral sign, again log z square. You can use properties of logarithm here. Because of this log, you know that because of this log, and with the help of the properties of logarithm, you can make this power as coefficient. If there is log, this power 2 becomes the coefficient of log z. That is, it will be 2 log z divided by what is root over z square? You know that this is z into this is z dz. So here this z gets cancels. So I think you have understood it. So it is 2 2s are 4. So 4 is taken outside. So you can multiply these two constant. 2 2s are 4. It is 2 2s are 4. Integration of, this is your log z dz. This is integration of log z dz. Now you know that this is integration of only one function, log z is there. I already told you that while doing the previous problem, if you have integration of only log z, or if you have integration of only inverse circular function, then also you have to use integration by parts. So actually there are two functions here. One is log z and the other one is 1, that is x to the power 0, and this one can be taken as algebraic function. Okay, this is log z L and x to the power 0 or 1 as algebraic function. So among these two letters L and A, which letter comes first in the word late or islate? L, logarithm. L comes first, isn't it? So log z is the first function out here. Or I is equal to 4 within third bracket. This is your log z integration of dz minus integration of second bracket. This is d by dz of log z integration of dz, second bracket closed dz, then third bracket is closed. And outside third bracket there is 4, right? Or I is equal to, now this is 4 within third bracket. Let us integrate dz first. That is, what is integral sign? 1 dz, that is z. This is log z minus integration of, what is d by dz of log z? It is 1 upon z into, what is integration of dz? Z. Then you can write dz. So here z gets cancelled. So let us multiply it by 4. Let us open this bracket. 4z log z minus 4 integral sign dz. Okay. So or I is equal to, this is 4z log z minus 4 into, what is integral sign dz? That is your z. Then what do we write? Plus c. Okay. Now you can put the value for z. Actually, what was the value for z? Since z square is equal to x plus 1, so what is z is equal to? Root over x plus 1, isn't it? Or I is equal to 4 root over, this is x plus 1 log root over x plus 1, right? So minus 4, what is z again? It is root over x plus 1. Then plus c. So you can keep the answer as it is, or you may take common from both the two terms. Okay. So I think you have understood it. So this is the answer. So you can copy it. So this much is for today. So today we did only 5 problems, and one problem was your homework. You can do it at home, and you can revise all the problems that we did so far on this chapter, integration by parts. And in the next online class, we will do more problems on this integration by parts. So this much is for today. So you can copy it.